Hi team, welcome to Wiggins Maths. In this video we're going to be modelling and problem solving with some parametric equations. Okay, so our first example, these generally look a little bit more tricky, but you just have to go with what we already know, and the answer to that is normally quite a bit more than we think. So here we have a parametric x in terms of t, y in terms of t, but we've also got this extra variable a. So hopefully we'll have some extra information on that. So a is non-zero and c passes through this point here. I suspect that will be very important. Okay, so part A, find the value of a. So let's write down what we know. So the x-coordinate here is -4. So I know that this is true. And I also know the y-coordinate at this point is 0. So 0 is equal to a lots of t cubed plus 8. Now, can we work out the value of a at this point? I am going to suggest that we cannot. However, what we could do at this point is work out the value of t. Not through this equation here, but through this equation here. See, it's in factorised form already, and we can make it equal to 0. So a could be equal to 0 here, right? Wrong. A is non-zero, so don't fall into that trap. However, t cubed add 8 could equal 0, and that's suggesting that t must be -2. So let's now substitute t equals -2 into this equation here. So we're going to get 4a subtract 2, so -2 equals 4a, which means a is equal to -1/2. Lovely stuff. Right, okay, so part B. Find the coordinates of the points A and B where the curve crosses the y-axis. I don't know why it tells us that in the question. Here's the diagram, clearly cuts the y-axis. And what does that mean? It means that x equals 0. So 0 is equal to -1/2 t squared, because of course we now know what a is, and we can factorize this. So take a factor of t out, we've got -1/2 t add 1. So this will generate two values of t. We'll have t equals 0 and t equals 2. So what happens when t is equal to 1? When t equals equal to 0, we get -1/2 lots of 0 add 8, so y is equal to -4. And what happens when t is 2? We get -1/2, 2 cubed add 8, and we get y is -8. So what does that tell us? It tells us that a must be the coordinate 0, -4, and b must be the coordinate 0, -8. Lovely stuff. Right, okay. I really like this example. It's one of those questions that initially looks really, really tough, and then when you break it down, it's incredibly straightforward. Okay, so we're told x in terms of t, y in terms of t, and we're told that it meets the curve at A with this line, so i.e. these two things are equal, they intersect. So what we can do is we can substitute straight into here to find out the values of t. So I can write down t squared add 4t add 4 equals 0. So that was what x is, t squared, and y is 4t. Okay, so we've got a quadratic here. Could use our calculator function, or we can spot that we can factorize it in this way, and that implies that t must be equal to -2. So now we have our value of t, we can substitute that back into x and y to get our coordinates. So x is going to be -2 squared, which is 4, and y is going to be 4 lots of -2, which is 8. So the coordinate a must be 4, -8. So quite a nice simple question once you break it down into its different components, and that in an exam would be worth quite a few marks. Ready to panic? Oh, what is this? Don't panic. Okay, it looks difficult. It's really, really not when you think about it. So here we have some model of a stone being thrown off the top of a cliff. We're told some information that is absolutely irrelevant, like for example the initial speed, the angle. We're not going to be using them in this question. Okay, this is on a pure examination. This would require the skill of applied mechanics if we were asked to solve this in more depth. So what we're going to do here is we're going to read the information really, really carefully. So x is the horizontal distance, so x is horizontal, and y is the vertical distance from the ground, and k is a constant. Let me draw your attention to our restriction on t. The starting value of t, the end value of t. Let's think. So t equals 0 right at the start, t equals k right at the end. And we also want to find the value of k, well, is 0. So we're going to set, for part A, this horrible looking quadratic equal to 0. And, you know, we can substitute this straight into the quadratic formula, or we could use the function on our calculator. But we get the values t is negative 1.926, and we also get t is equal to 2.648. Now, which of those is going to be the correct answer? Well, contextually, t is time. We've been told that t is greater than 0, so we're going to take t as 2.65 in this case, to 3 significant figures. So that tells us that k must be 2.65. Okay, so that's a good start. And then part B, find the horizontal distance travelled by the stone once it hits the floor. So the horizontal distance is x, so x is equal to 5 root 2 over 5, lots of t, and the value of t at the end of its journey is k, and k is 2.65, so therefore x must be 5 root 2 over 5, 5 root 2 over 2, apologies, multiplied by 2.65, which when you type it into your calculator comes out as 9.362, and so on. So therefore we should probably write a sentence here. So the horizontal distance travelled is 9.36 meters to 3 significant figures. And now we're done. That looked like a really horrendous question. You know, the diagram is really, really off-putting, but just read that information really carefully and it's not too bad at all. Okay, as always, watching the video doesn't mean you'll instantly be able to do it. You need to make sure you practice, particularly contextual questions, particularly those that look more complicated than they actually are. And the more you practice, the better you will become. And of course, amateurs call it genius, masters call it practice.